Go ahead and get started. Good evening to you. I hope you've been having a good day so far. So this course is focused on the mathematics section of the GED exam, as I'm sure you're well aware. And the goal of this course training is to help you build and refresh foundational skills that you'll need to pass the mathematical reasoning exam. So by the time that this course ends, you should be able to do basic math. You'll have completed geometry and basic algebra exercises, and you'll be able to evaluate graphs and functions. So the syllabus is available for you to access via Google Classroom, but Lisa, I know you mentioned that you weren't able to see it, and I'm guessing other students might be having the same issue. So I'll try to repost it again today after class. The lecture slides are up as well, but I'll repost those just in case. Let me know after class if you're still having issues accessing the posted documents. And so just a quick reminder, class meets every Tuesday and Thursday from 6 to 9 p.m. via Zoom. Class attendance and participation is very important. Attending class will ensure that you're receiving the necessary tools and skills that you need to complete the math portion of the GED. And I'll also be reporting attendance for every class. So regular attendance is required. Please be on time. If you need to be absent for class for any reason, please notify me. It would be best to notify me the day before, but as soon as possible. Emergencies happen, so I understand that. Every student is expected to work through the covered class material and complete assigned homework. So if you've already completed 40 or more hours of attendance since your last assessment, you'll be eligible for progress testing. So keep track of your attendance hours as well, and I'll be doing the same. And then once you reach 40 hours, if you're interested in progress testing, just let me know. So you may already know that there's no grading for this course, but there will be chapter review quizzes every week, beginning next week. So a practice exam is also scheduled for week 11 towards the end of the course. After the practice exam, there will be a final review of the course material, which will also take place week 11, I should say. And like I said earlier, you must have earned at least 40 hours of attendance to be eligible for the next steps. So I'll share information with you about your eligibility towards the end of the course. So even though there's no grading of your assignments and of your assessments during this course, it's still very important for you to attend class and to do the homework, take the weekly quizzes and the final exam, because all of the effort that you're putting in will be counted as hours, which will then determine your eligibility to take the GED exam. So please take some time to read the syllabus. Again, I'll post that as soon as class ends tonight, so that you'll be familiar with the course expectations in terms of attendance and preparations that you need to make to get ready for the GED math exam, which is scheduled for week 14, and that's the week of January 2 to 5, 2024. So your GED textbook is by Caren Van Slyke, and the ISBN number, I provided that on the slides as well as on the syllabus, just to make sure so that you can make sure you're purchasing the exact book. And I've also put a little snapshot of the front cover so that so you can identify the book when you're making your purchase. There's several resources that you can use to further your understanding of the course material. Khan Academy is one. The class code will be shared at a later date, and there are lots of educational videos on there that you can watch to help you along your learning journey. Kaplan Online Center is also another great resource. Once you register your book using your ISBN number, you'll have access to a series of practice tests that are really an excellent way of helping you get ready for the GED exam. Okay, so without further ado, let's get started with chapter 1 of the math reasoning portion of the GED exam. And chapter 1 begins on page 546 of your textbook if you already have the book. And this chapter essentially covers number sensing and problem solving. So number sensing is simply the process of understanding and relating and connecting with numbers. So for example, when you're trying to put a set of numbers in order, you need to consider where each number is placed. And that's what's known as the place value of a number. And we'll talk about that more extensively this evening. So when you're ordering numbers, always compare the same place value between numbers. And sometimes when you're comparing numbers using place values, you need to decide which value among the group of numbers you have is the largest. And so in such a situation, when you're making your comparison, if the values that appear to the left side of your decimal point are the same, then you can get a better understanding of the sizing value of each number that you're comparing relative to other numbers within the group by looking at the digit that appears to the right of the decimal point. And this is called rounding. And again, we'll talk more about that as the evening progresses. So as you're sensing numbers, and remember that sensing just means that we're trying to understand, relate, and make connections with numbers. So as you're sensing numbers, when you see a decimal point, know that you can round numbers up or down, and this will help you determine really how big a number is, especially when you're comparing groups of numbers that are almost within the same category in terms of maybe the first 3 numbers are the same. After the decimal point, you can make a final assessment as to which number is bigger. And again, I'm just talking in generalities here, but I'll get more specific as the evening goes on. So the first concept or the first lesson in comparing and ordering numbers is place value. So place value is the basis of the entire number system. And I'm going to use the terms digit and grouped numbers to explain. So think of digits as individual numbers like 1, 2, and 3. And then think of grouped numbers as putting those individual digits together. So if we put our individual digits 1, 2, and 3 together to form a grouped number, we have 123, for example. And we can obviously order those numbers around 321, 231, but the idea is for you to keep in mind the definition of those two concepts because they'll come up a lot this evening. So again, digits are individual numbers like 1, 2, and 3, and then our grouped numbers is when we take a bunch of digits and we group them together, essentially. So as an example, you can think of the number 20 as 2 groups of 10. So since 10 times 2 is 20, or you can also think of the number 20 as 10 groups of 2. So for example, if you have 2 $10 bills, then you have a total of $20. Or if you have 2 $10 bills, you also have a total of $20. And so these are conceptually, I'm trying to, guys, you use math every day without realizing it, determining your grocery bill, how much money are you going to send to this person based on what you have in your account, right? But now we're just adding more formal mathematical conceptual terms to activities that you're already used to doing. Back to our definition of place value, then, the position of a particular digit within a grouped number will determine the value of the digit in question. So using, again, our example of having $20, the 2 represents the tens position. In other words, you have 2 $10 bills in the tens position. And the zero means that you have 0 $1 bills, for example. I mean, obviously you can have $21 bills, but just for the sake of this example, in the tens position, we have 2 tens, and in the ones position, we have 0. So if we want to consider a larger number like 350 that I have illustrated here, we can see 3 individual digits. We see 3, we see 5, and we see 0. And these 3 digits, when we put them together, they form the number 350, right? So if we're looking at 350 as a grouped number, the 5 there represents the tens or 5 tens. So 5 tens or 50 is the place value of the digit 5 here. Before I move on to the next slide, I just want to check in with you guys and see if you're okay, if you have any questions.
Nope, I'm all good.
Okay, great. So still on the concept of place value, as I just mentioned, the value of a grouped number depends on the place values of the digits in the grouped number. So let's revisit the grouped number 350, but this time in terms of money so that you can have like a better idea of what I'm trying to say. So let's say you have $350. The position of the 5 here means that you have 5 in the tens position, or you can think of that as having 5 $10 bills, or yeah, let's leave it at that, 5 $10 bills, just to make it easier. If we add an extra 0 to the end of that 350, now you're becoming a little richer, right? You've gone from having $350 to having $3,500. But did you notice what happened to the digit 5 that I highlighted here in the slides? Did you notice that 5 moved over to the left by 1 position? So in other words, the place value of 5 changed. So when you hear place value, don't get nervous. It's just a fancy term of saying what position is your number in, and how does that position determine the value of the grouped number as a whole. Okay, so as you can see, when a 0 is added to 350, the digit 5 moves from the tens place over to the hundreds place. And so you can think of that as having 5 $100 bills. So now you've gone from having 10 $5 bills to, no, excuse me, 5 $10 bills to 5 $100 bills. So after adding to the, after adding 0 to the end of 350, its place value of 5 jumps from tens to 500s. And if you look inside that purple box that I have highlighted there, you can see an illustration of what's known as the number line. And basically, it's just a great visual aid to help you imagine and recognize the place value of a particular digit within a number. So inside the purple box, we see that the number 1,400, we see the number, 1,479, right? And so when you see this grouped number, your brain immediately knows that each digit has its own place, and the combined placement of each digit determines the value of the entire number, right? And so if you see your phone bill, your phone bill is $1,479, you know that each one of those digits has its own unique value that when put together determines the size of that number. So in this particular situation, even though if we're just speaking generally, 1 is less than 4, and it's also less than 7, and it's also less than 9, but because of the place value of 1 in this particular situation, 1 has the greatest value. because it's in the thousands position, or it's in the thousands place in the number line. Okay, and then so the next greatest value is 4. And again, even though we know that 4 is less than 7 and it's also less than 9, because of its particular position or its place value on the number line for this particular grouped number, 4 is the next greatest value in this example. Okay, and then obviously 7 is the third greatest value because it's in the tens position, and then 9 is in the ones position. So it would benefit you a lot to understand this number line, and I think it would be a lot easier to just think of it in terms of money. So you have, if you have $1 million, or maybe let's say you want to start with 1, and then you add a 0 to that, all of a sudden you have $10, and you just keep adding zeros until you hit a million, right? It's essentially the same concept. So not to belabor the point, but I just want to make sure that you guys understand. You can see that this number 1479 would increase the value with each move to the left of the number line. So for example, if we move the 1 from the thousands position over to the left to the 10,000s position, and then in place of the 1, we put a 0, all of a sudden we've gone from 1,479 to 10,479. So essentially, the point that you should, or the key takeaway that you should be getting from this example is that the place value of a number is very important in determining the size of the grouped number. I'm going to pause to see if you guys are okay, if you have any questions.
No, I'm still good.
Okay.
I'm following.
Okay, great. Frank, you good? Is he there? France, sorry. I'm going to assume that you're okay.
It's okay.
Okay, great. So there are 5 inequality symbols in math that you should know. So let's go over them in the order that they appear on the slide. The first symbol is less than, which looks like the tip of an arrow that's pointing to the left, right? And so when you see that, automatically know that whatever's on the left of the tip is less than whatever's on the right. So for example, if you see 5 and then you see this arrow that's pointed to the left, and then you see 25 on the right hand side, you know that there mathematically what the person on the other side of that is trying to communicate to you is that 5 is less than 25. Okay. The second symbol that you should pay attention to is less than or equal to, and that essentially just looks like the tip of an arrow pointing to the left with a line underneath it. The third inequality symbol is an arrow facing the tip of the arrow facing the right hand side. And that symbolizes the greater than. So if you saw 25 on the left hand side, and then you saw 5 on the right hand side of the symbol, you would know that that's telling you that 25 is greater than. Okay. The third symbol is greater than or equal to, and that essentially is the same concept, just for situations where you're dealing with inequalities. And I don't want to get too much into that because it's not dealt with in this chapter of the book, so I don't want to complicate the lesson. But I guess it's just good for you to know that if you see an arrow, a symbol with that's looks like the tip of the arrow is pointing to the right with a line underneath it, just know that conceptually it means greater than or equal to. Okay. Friends, can I ask you to turn off your video, please? Because it's covering the, thank you very much. All right, and so the final symbol, the symbol is not in your textbook, but I thought it was worth mentioning because it's one that you might see, I'm not sure. But just in case, if you see an equal sign with a line going through it, it's essentially telling you that it's not equal. The numbers on the left-hand side is not equal to the number on the right. So for example, if you see 5 and then you see does not equal to with the line, the equal sign with the line
Are
going through it.
different.
I'm sorry?
They are different.
Exactly, thank you, yes. So like I said earlier, the first four that I mentioned are the ones that you should pay attention to, but just in case, you now know what the fifth one means as well.
Okay.
Okay, any questions so far?
Oh, that's good.
Okay, alrighty. So in terms of comparing and ordering values, let's say that you have more than one number and you need to put the numbers that you have in a particular order. To put more than one number in order, you first need to determine which of the numbers is greatest, right? And which is least. And then maybe even which, if you have more than two, which go in between your greatest and your least. And you do this by aligning place values. Aligning the place values of each of the numbers that you're comparing. So in order to align your numbers so that you can make your comparison, you would want to start at the left of the number and then determine the value of the first digit of each of the numbers until you have run through all the digits in the number group. So for example, you've been asked to order 342, 98, and 317 from least to greatest. How would you proceed? Does anyone want to suggest?
Well, it would be 98, 317, and 342.
Yes, perfect. But how did you come to that conclusion? What did you do to determine where each number should be placed?
Well, 98 is for me, it has two numbers, so it's the smallest. It's gonna go first.
Yeah, perfect. That's
Then
actually,
the other two, the next one, that's the least number. So that would be 317.
yes, that's exactly it. So you start by comparing the first digit in each of the numbers. And like you said, 98 only has two digits compared to the remaining numbers that both have 3 digits. And so you determine that 98 is the smallest number. And then you move on to the next. You know that looking at 317 and 342, remember that we start with the first digit on the left, right? And so both numbers have 3 in the first digit in the hundreds place. So you then move to the tens place, and 317 has a 1 in the tens place, and 342 has a 4 in the tens place. And since 4 is greater than 1, you determine that 342 is greater than 317. So from least to greatest, we have 98, 317, and 342. And this is what I was trying to tell you guys earlier, that you already use math in different ways every day. We're just, I guess, putting fancy terms to things that you already do, right? So there's actually no reason to be scared of this portion of the exam at all, because you already know all this stuff. It's just a matter of now you getting used to the more formal terminology that's added to the information that you already know, right? Okay, so again, place value is essential to rounding numbers. For example, if you've been asked to round 2,451 to its nearest value, you would start by locating the place value that you want to round to. And in this case, it's the hundreds place that is king of the show, for example. And so in the hundreds place is the digit 4. So now look to the right of 4, and if the digit is 5 or greater, you know that you can round up. And if the digit to the right of 4 is less than 5, don't change the number in the hundreds place. And so this is where the concept we talked about earlier, less than or equal to, becomes, or greater than or equal to, becomes important, right? Because if we're looking at 4, the instructions tell you that if the number to the right of 4 is greater than or equal to 5, you should round up. And what number do we see highlighted there? 5.
5.
Right? And 5 is equal to 5, right? So what do you think we're going to do here in this situation? We're going to round up, right? Because that's the rule. Anything that is either 5 or greater than 5, you round up.
Okay.
And anything that is less than 5, you round down. So if the number is exactly 5, that means you round up, because that inequality tells you that it's either greater than or equal to. And 5 equals 5, right?
Yes.
So we round up. Okay. So I'll give you an example that may make this a little bit easier to understand in terms of an everyday activity. So again, the goal here is that we need to round up the number in the hundreds place. And so that's 4, right? And we remember our number line?
Yeah.
1 is in the ones, 5 is in
5
the
is in the
tens.
tens, 4 is in the hundreds,
Yes. And 2 is
2 in the thousands.
perfect. And so the person who created the test is saying, hey, friends, we need you to round up 2,451, right?
Yeah.
And so what you want to do, since there's no number greater than 2,000 in this group, the next number you would look at is 4,
Okay.
right? Because it's in the hundreds place, right?
Hundreds place. Yeah.
And so let me use a scenario. Let's say, for example, your boss has asked you to use Google Maps to calculate the distance from one-way distance from your office to Alaska, for example. And let's say you figure out based on the distance, he wants to relocate you to Alaska, and he wants to know how much he has to give you to buy gas for you to get there. And so you figure out based on the distance that it's going to cost you $2,451 to get to Alaska, right?
Yeah.
But you don't want to ask for exactly $2,451 because you figure maybe on the way there, there'll be traffic, you have to sit in traffic, and that burns gas, right?
Yeah.
So you don't want to ask for the exact amount, but then you also don't want to ask for too much money, because the reason he's sending you to Alaska is because he thinks you're such a great, you're so good with budgeting and you
Okay.
don't waste money, right?
Yeah.
So you want to give him a number that will get you to Alaska, but will also keep you looking like the wonderful budget guy that you are.
Yeah.
So
A fair price.
yes, so in this scenario, you would look at the hundreds place, and the
Okay.
number to the right of the hundreds place is 5. So you would want to round up the hundreds place.
Okay.
So you would then tell your boss, hey, I'm going to need an estimate of $2,500 one way to buy gas one way to Alaska, right? So you
Yeah.
haven't given him the exact $2,451, but you've given him an estimate that will cover you just in case you have to sit in traffic and burn gas,
Yeah.
right? I mean, that's a very silly
Very clear.
example, but
Mm.
you know, hopefully it helps you, it helps drive the point home.
Yeah.
Okay. Jaleesa, are you okay?
Yeah,
Okay, good.
I understand.
Okay.
All right.
So, on when you're working on the test, the practice test, for example, or even taking the actual test itself, one way that you can check your answers is to round numbers in the problem and then find the approximate answer. Because sometimes I mean, you might see an answer that's close to what you have, but it's not quite there. So you can use rounding to kind of help you get to the approximation, if you understand what I mean.
Mhm.
So there are, excuse me, practice tests on comparing and ordering numbers that start on page 551 to 552. And I encourage you to work on that. Again, that will count towards your hours, your eligibility hours. But also the thing with math is that it's really about practice. The more you practice, the more you get used to it, the easier it becomes. Like earlier when I was telling you when I was asking you rather, which number is greater, 97, 317, or 342,
Mm.
you knew that because somewhere in your daily life, you've been ordering numbers so much that it's become natural to you, right? And so I really encourage you to do the practice tests. It'll just help you feel comfortable with the material so that when you're on the test, it takes away the nerves and you can focus on the questions and answering them as
Okay.
best you can. Okay, so now on to lesson 2, which focuses on whole number operations. And so the key ideas to note here is that when you're combining amounts that involve addition and subtracting amounts, excuse me, when you're combining amounts that involves addition, and when you're subtracting amounts, you're essentially taking the difference between two numbers. Okay, so again, combining involves addition and subtracting means that you're finding the difference. So I'm explaining that just in case you see, because you'll come across word problems. And sometimes when you read a word problem, you have no idea what to do, but you can look for keywords. So if you see words like combine, or words that sound like combine, they're asking you to combine a group of numbers, you know that they're asking you to add. Or if you see a question that says, find the difference between 59 and 40, well, that would put you in the negative, 59 and 22, you know that they're asking you to subtract 50 from 22 from 9, and then find the final answer, right? So pay attention to terminology because it can really help you answer the word questions, and we'll get to those towards the end of the lesson. So when you're either adding or subtracting, excuse me, the first thing you want to do is align numbers in order of their corresponding, guess what, place value, right? And look at the next place value and you may need to regroup if you're adding numbers, and we'll get to that. You'll understand what I mean in a little bit. So again, the concept of place value becomes key when you're adding and subtracting numbers. So when you want to combine amounts using addition, the final value that you get from adding several numbers together is called the sum or the total. So again, on the test, they're not going to say add 50 plus 60 plus 75. They might phrase the question as find the sum of this group of numbers. And when you see the word sum, you know immediately that they're asking you to add, right? Or if they say find the total, you know that they're asking you to add. So when you're adding, be mindful to stack the numbers in a column, and the next slide, the next couple of slides will explain what I mean, so that you can easily assign place values for each of the numbers that you're working with. And then once you've lined up your place value columns, that you want to start working from right to left, starting with the ones column and then moving to
hundreds.
Yes, until you get to the end of however large the number that you have been given, right?
Okay.
So the digits in if the digits in one of your place values adds up to 10 or more, then you need to regroup to the next place value. And we'll talk about that some more in the slides that follow. So in this example, you're asked to add 40 plus 129 plus 24. And so you want to stack your numbers in columns like I was explaining earlier. So it doesn't really matter, since you're adding, it doesn't matter what order. You can put the smallest one first if you like. So you stack your numbers 40, 129, and 24. And then you want to start working from left to right, right? And so, I'm sorry, from right to left. Did I say left or right? I'm sorry. You want to start working from right to left, right? And so you want to add the numbers in the ones column first, right? And so 0 plus 9 plus 4 is 13. So what you're going to do is write down the 3, and then we have to regroup. And that means that we carry the 1 over to the tens column. Okay?
Yeah.
And so, excuse me, since the total in the tens column is now 9, because 4 plus 2, 6,
plus 2, 8.
Plus 1, 9.
9.
You write down 9 here.
Yeah.
Right? And then in the hundreds column, since it only has 1 digit, you write down 1. So now we have our sum total, which is 193, right? And so again, these are basic operations that you already do every day. You already know what 0 plus 9 plus 4 is, and you already know what 4 plus 2 is. But in this situation, because we had to regroup and carry 1 over, we're adding 1 to the tens column. We have nothing but 1 in the hundreds column. And so we know how to add this number without a calculator, right? It's just a matter of first stacking your numbers and then working from right to left starting in the ones column. If your total in the ones column is greater than 10, is 10 or greater actually. So because you can't, like, if this ones column had added up to 10, for example, you can't just write down 10 here, right? Because you would get the wrong answer. You would write down 0, carry the 1 over, and then continue adding. Again, if your total in the tens column is 10 or greater, you would write down the number to the right of whatever value you have, and then carry over whatever's on the left. And you continue to do that until you get to the end, right? And so this is just showing you how to add numbers without using a calculator, which would be a wonderful skill to have just in case, for example, you're trying to buy stuff from a vendor and he's telling you the wrong price. You can do the math in your head and go, no, I remember. Right? And you do the math in your head and you tell him that's not the price, right?
Yeah.
So, okay, so on to subtraction. The difference with addition, like I was telling you earlier, you can just put the numbers in whatever order you add. It doesn't matter if you add 40 first, and then 121 or whatever that number was after 40, I don't remember, and then 24, or you decide that you want to start with 24 and then 40. It doesn't matter, you'll get to the same answer. But with subtraction, it's important to start by writing down the greatest number first and then continuing in descending order, because it's going to make a difference in the answer that you get, right? And with the same with addition, you may need to regroup when you're subtracting. If your answer in one of your columns, either ones, tens, or hundreds, so on and so forth, is greater or equal to the number 10, okay? So in this example, we're told that Sue is 57 years old and Kathy is 38. And we need to find out how much older Sue is than Kathy, right? And so, like I said earlier, you want to start with the largest value, which is 57, because if you put 38 first, you would end up with a negative number, right? And negative years don't exist, right? That's maybe somebody died, but so like in the practical sense,
Yeah.
you always want to start with the largest number. So once again, you would start with the ones column after you've stacked your numbers, and notice that in the ones column we have 7 minus 8, right? And well, technically 7 minus 8 is -1, but for the purpose of this exercise, we can't do that. We need to go over to the tens column and we need to borrow a 1 so that our answer will be positive, right? So we go over to the tens column and we borrow a 1 from 5 and we write down 4 to help us remember that we've borrowed a 1. And now when we move 110, or you can think of it as $10, 110 over to the right, we now have 17. Now we can do our subtraction and get a positive number. So 17 minus 8 is 9, right? Then we move to the tens column to continue with the subtraction. And so we know, since we removed a 10 earlier, so that we could complete our ones subtraction, we know that 4 minus 3 is 1, right? And so we figured out that Sue is 19 years older than Kathy. Okay?
Okay.
So again, same concept here. We're being asked to find the difference between 205 and 67. So again, you want to place your numbers in a column, and then starting with, place your numbers in a column starting with the largest one first. And then once you've done that, go to the ones column, okay? And we see the 5 is less than 7. So we need to go over to the next column to borrow a 1. But when we move over to the next column, we see that there are no zero.
There's no tens.
Yeah, it's essentially 0 tens. So you need to move over to the hundreds column to borrow a 1, right? And so you write a 1 above the 2 to help you remember that you've borrowed a 1. And you can now add that 1 to your tens column. And now you have 10. And now that you have 10, you can borrow a 1. And you need to write a 9 above that 10 to help you remember that you've borrowed a 1 from 10. And
Okay.
you add that 1 to 5. And now you have 15.
Okay.
Okay. And then 15 minus 7 is 8. And you want to make sure each time that you're borrowing from whatever column you're in, you're crossing out the original number and adding the new number so that you don't forget, right?
Right.
So now that we've regrouped, and we now have 9 in our tens column, we're going to subtract 9 from 6, and that gives us 3, right?
Right.
And so the final column, we remember we said we borrowed 1
One,
earlier.
2.
We only have 1 left, and there's nothing under 2, so 1 minus 0 is 1. And now we know that 205 minus 67 is 138. And you can check your number by adding 138 to 67, and conceptually you can imagine, let's say you have 205 bucks and you want to buy an item that costs $67, right? But you don't feel like counting the money that you have to make sure that you don't feel like counting the $205. So you give the entire thing to the cashier, and the cashier gives you back $138. You'll know that they gave you the right change if you add the price of the item, which is $67, to 138, which would give you the original amount you had in your pocket, which is $205.
Yeah.
So when you're taking the test and you're doing subtraction, you'll know if you have the right answer if you subtract what you, if you add what you find to the smallest number, because it should add up to the largest, right?
Right.
And so again, there are practice tests on page 556 to 558 on whole number operations. So I encourage you to work on those. And as you're working on them, if you have any questions, don't hesitate to contact me. All right, so the next concept is multiplication and division. So to multiply, essentially, you're combining the same amount multiple times, right? So in this example, instead of adding 24 3 different times, you can simply multiply 24 by 3. So if you see a question that asks you to find the product of a group of numbers, you know that they're asking you to multiply the relevant numbers, okay? So in this example, we're asked to find the product of 24 and 3. excuse me, 24 and 63. So you always want to start in the ones place. Multiply the ones in the top number by the ones in the bottom, number. So 4 times 3 is 12. And so since 12 is greater than 10, you want to write 2 and carry the 1 over. So just maybe as a helpful hint, anytime that you're in the ones column and you have a product, so you've multiplied 2 numbers, or you have a sum, you've added 2 numbers, or you have a difference, you subtracted 2 numbers, that that leaves you with 2 digits, in this case 12. We have 1 and 2 digits. You want to write down the digit to the left, the digit to the right, okay, and then carry over the digit on the left. So in this case, the digit on the right is 2. You write that down and carry over the digit on the left, which is 1, okay?
Okay.
So once you've multiplied 3 by 4, you move over, we're still working with 3, you move over to the tens column, and you want to multiply 3 by 2, okay, which will give you 6. And then you need to add the 1 that you've carried over, and you would write down 7, okay? And so, yeah, this essentially what I just explained. Again, you want to start with the ones, okay, and then multiply first the top number, and then the second number. If there's a number to the left of that, you would include it, and so on and so forth until you continue with the numbers in that particular row before you move on to the next place, right, which would be the tens. Okay, so now we've completed the multiplication of the ones place, right? We've multiplied 3 by 4, and we've multiplied 3 by 2, and we have 72. And now we're going to move over to multiplication in the tens place. So 6 times 4 is 24. We're going to put 0 under 2 as a placeholder, and to remind us that we're no longer working with the ones place because we've completed our multiplication for the ones place. As I said earlier, we've multiplied 3 by 4, and we've multiplied 3 by 2. So we're done with ones now. We'll put a 0 there. And now we're in the tens place. And so we'll start 6 times 4 is 24. And again, that multiplication gives us a 2-digit number, which is 24. So we're going to write down 4, and we're going to carry the 2. Okay, and then we move over to the tens place, excuse me, to the second number that we need to multiply, which is in the tens place. 6 times 2 is 12, but because we've carried over 2 from our first tens multiplication, because we carried over 2, 6 times 2 is 12, plus 2 is 14. And so you would write down 14 in its entirety. And the reason you would write down 14 is in its entirety is because there's nothing else left, right? If there was a 3 here, for example, you would write down 4 and you would carry the 1 above the 3, okay? But since there's nothing left, we write down 14, and now we can add 72 to 1440, and we know that 63 times 24 gives us 1512. Okay?
Okay.
Do you want me to repeat anything?
That's fine.
Okay. So now on to division. And so to divide means that you need to find out how many equal parts are in a given amount. Or put it differently, how many equal parts in a given amount can you get from dividing the divisor, which is the number on the bottom of your division line, into the dividend, which is the number above your dividing line, okay? And the answer that you get is called the quotient. So the number below is always called the divisor. The number above is called the dividend, and the answer when you divide your dividend by your divisor, the answer that you get is the quotient. And I'm not trying to complicate things, but I am using those words because you'll see them in word problems, right? For example, if you're asked to find the quotient between two numbers, between a divider and a dividend, you know that they're asking you to divide whatever the divisor is. Let's say the divisor is 5 and the dividend is 25. You know that you're being asked to divide 5 into 25 to get the quotient, which is also 5. Okay. Okay, so in this example, we're told that 3 children sold their toys at a garage sale for a total of $54. And we want to know how much each child should receive if they have to share the money that they made equally. Right, so we need to split 54 3 ways, essentially. And this time you want to work from left to right, okay? In all the examples that we've worked on so far, we've been working from right to left. But when you're dividing, you always want to work from left to right, okay? So the first question you should ask yourself is, how many times does 3 go into 5? Well, we know the answer is 1, right? So you would write 1 on top of the dividend, which is 54. 3 times 1 is 3, okay? And so then you would subtract 5 from 3 and you have 2, right? So far, so good?
It's okay.
Okay.
Yep.
Okay. And so you subtract 5 from 3, you have 2, but don't forget, we still have 4 to work with. So you want to bring down the 4, right? And then the next question you should ask yourself is, how many times does 3 go into 24? The answer is 8. And you can check yourself because 8 times 3 is 24. So you write down 24 and you subtract 24 from 24, you get 0. And that just tells you that now we're done with this division. There's nothing else to bring down. And we've subtracted what was remaining from our division. We subtracted it and there's nothing left, right? So we know that each child should receive $18. Okay, I'll explain this again or using different words just to make sure that it's clear. Okay, so we've asked ourselves how many times 3 goes into 5, and we've decided that the number is 1. The answer is 1. So you multiply 3 by 1, and 3 times 1 is 3. So you write down 3 under the 5. And why do we write down 3 under the 5? Because we're working with 5, okay? And then you draw a line under that because essentially you're telling yourself, okay, we're done now with the tens column, okay? So you draw a line under that. Every time you finish with one column, you draw a line. So here we finished with the tens column. We know that 3 times 1 is 3. Write down your 3 and draw a line. Then you want to, subtract 5 from 3, because essentially you're saying, okay, we know that 3 goes into 5 one time, but there's 2 left over, right? And we need to do something with that too. So you draw your line and you subtract 5 from 3, and there's your 2 that's left over. And now you bring down the 4, okay? And so essentially you're telling yourself that you've successfully divided 3 into 5. There's 2 left over, and you've brought down 4, okay? And now you need to ask yourself, how many times does 3 go into 24? And the number is 8, right? 3 times 8 is 24. Don't get confused, right? These are 2 different values. This 2 came from our subtraction from 5 and 3. This 4 came down from bringing this particular 4 down. And then this 24 comes from multiplying 3 by 8. And I'm stressing that because you may not get, you'll get something completely different from this on the test, and you don't want to get confused. So you want to keep track of what's going on with division, right? And I find that with division, you have to pay particular attention because there's so many steps. But if you can keep the steps in mind by just asking yourself questions, you'll be able to keep track of what you're doing. So here we know that we're done with the, you can ask yourself, so are we done now with the 10th column? Yes, the answer is yes. Draw a line. Subtract 5 from 3, get 2, bring down the 4. Then what's next? You got to keep dividing. So 3 times 8 is 24, right? So you subtract 24 from 24, you get 0. You have nothing left. And so you know that each child should receive exactly $18, right? With no change, equal parts, okay?
Okay.
In this next example, we're being asked to divide 1006 by 4, right? So again, working from left to right, we're going to start with 1, okay? And it's very important that you remember division is the only time that you work from left to right. Every other scenario, you work from right
to left.
Okay? So working from left to right, you want to ask yourself, how many times does 4 go into 1? Well, 1 is less than 4, so we know that that doesn't work. So we got to move over to the hundreds column. Remember, we started with the thousands, right? Started on the left. So we move over to the hundreds column. And now you ask yourself, how many times does 4 go into 10? Well, the answer is 2, right? So you write the 2 above the 0, not above the 1, because we don't have an answer for that. So you leave that blank, right? Because 4 doesn't go into 1. So you write nothing above that, okay? So 4 goes into 10 twice. 4 times 2 is 8. So now you ask yourself, are we done with the hundreds column? The answer is yes, so draw your line. 10 minus 8 is 2. Okay, And the very next step,
Bring down 0.
exactly. Okay, so once you bring down your 0, 4 goes into 20, 5
5
times.
times
4 times 5 is
20.
20, right? And so you subtract 20 from 20, you
0.
get 0, but you're not done, are you? Because you still have one number, right?
Mm-hmm.
So how many times does 4 go into 6?
1.
Exactly. And so you write the 1 where? Above the 6.
Yeah.
Right? And a good way to think about this is that you're basically just writing your answers above the corresponding number. So here the 2 comes from us having divided 4 into 10,
10.
right? And
Mm-hmm.
then the 5 comes from us having divided 4 into 20, right? We'll write that down here.
Mm-hmm.
And this 1 comes from us dividing 4 into 6, okay? And so we know that 4 times 1 is 4. So 6 minus 4 is 2. Now, if there was another number here, you would draw a line
And bring it down.
and bring that number down. So essentially, you would need a decimal point here since 1 is the last place. And just if there was another number here, you would bring that down. But since we don't have another number here, you indicate above your dividend, 1006, that your remainder is 2. And so essentially, what we've just found out is 1006 divided by 4 is 251. You'll have 251 equal parts, but then you'll have 2 left over.
Okay.
So that would be the equivalent of saying you have $1,006 that you need to divide between 4 people. Each person will get exactly $251, and then there'll be $2 left over. And you can decide how you want to split the $2 among the 4 of you, right? Something like that. Okay.
Yeah.
So I think this is a really good tip that also comes from the book. Essentially asking you to learn and review your multiplications tables because it will save you a lot of time on the GED, right? Like you saw how we were able to go through these pretty quickly because we know, for example, in this case, 4 times 2 is 8. You write down 8, you draw down you draw your line, whatever, and you keep doing that until you get to the end of the dividend, right? But you would be wasting a lot of time if you have to put into your calculator 4 times 2, right? It's a lot easier for you if you can do the multiplication in your head. And that's essentially what they're telling you here is memorize the times tables so that you can have an easier time, or you can get through the time through this timed test a lot quicker, right? So that you don't waste time on the using the calculator. So I'm not sure how you guys are feeling. Do you want to take a break? Do you want to keep going?
It's okay for me.
You're good? What
Yeah,
about
I'm
you,
good.
Jaleesa?
Oh, I'm fine.
Okay. So with calculator skills, you're gonna have a few questions that will require you to use a handheld or the online version of the TI 30XS Multiview scientific calculator. And there's a picture of it in one of the slides so that you have an idea of what it looks like. And you want to use the calculator when you think that it will save you time or it'll improve your accuracy, right? And so it's a good idea for you to get used to using the calculator because you don't want to waste time trying to figure out how to use the calculator on the test, right? That's the last thing you want to do. So you want to make sure that you know how to use the calculator before you get to the test, and that requires learning how to use the keys, understanding what the different symbols on the keys mean, and so on and so forth. So you're going to have access to either an online or a handheld calculator for many of the questions on the mathematical reasoning test. And for some of the questions on the social studies and science tests as well. So if you wish to use your handheld calculator, you would like, I guess you'll have to bring your own, and it must be a Texas Instruments TI-30XS multi-view, and that's what it looks like here. And then apparently the online version will also be available when the calculator icon appears on top of the computer screen when you're taking the test. So then you can click on the, excuse me, you can click on the icon to open the calculator, and you can use the mouse to move it so that it doesn't cover the problems, and you can work on it that way. But if you can get the calculator, I would encourage you to do that so that you can have time to practice and know how to use it before you get to the test.
Okay.
Okay, so looking at the reproduction of the calculator below, the arrows kind of show you what's going on and I guess explain the operation of the keys, right? So when you're doing your calculations, they're going to appear here on this side. So let's say you're adding 50 plus 5 plus 3, all of that will appear here, and then your answer to that will appear on the side, right? Which is 58. So you should see 58 here, right?
Okay.
And then this is the delete key on this side right here, the third key to the right. If you consider this the right-hand side, then this is the third key. These are arrows that you use to navigate the display. So for example, if you're asked to add 50 plus 5 plus 3, but you accidentally put 4, and before you press enter, you can use this left key to navigate to 5, delete it, change it to 4. Okay. This is the clear key that you would use in that instance. So you would navigate over to the number that you need to change using these arrows, and then you would click delete. I'm sorry, you would delete using this key, but you would clear using this key. Okay, sorry about that. So if you wanted to delete a particular number, use this key. But if you want to clear the entire thing,
Entire screen.
yes, use this key. And then these are your operation keys. So subtraction, addition, multiplication, division, those are called operations, right? And so these are your operations keys. These are your number keys or digit keys. You turn the calculator on here, and to find your answer, press enter, and this is your enter key here, okay? I tried to find the online version. The only thing that I could find was the online manual to these. So I think the online version is only available during the test, like they make that available. But I don't know. If you guys have better luck than me, I would love to know if you find it online.
Okay.
But the only thing I could find were manuals. I found other calculators, but they're not the same. And you want to get used to the actual calculator that you're going to be using. So Yeah, so again, a tip suggested by the textbook, buy the calculator for practice as you work through the book. Um, it may be available online. I tried to find it, I could not. But you can certainly buy it online, and you can find it in office supply stores as well, where calculators are sold. All right, so on to calculator skills. Like actual, I guess, operational examples on your calculator. You always want to start by clearing the screen. And you want to do that in case you were working on something else. Because if you don't clear the screen and you immediately start entering numbers, it might connect what you were working on previously with your new information, and guess what? The answer is going to be wrong. So you always want to make sure that you clear the screen and then enter each number followed by whatever operation is needed. So in this case, we're adding, right? So you would enter 63 plus 97 plus 58 plus 32 plus 81, and then press enter, and you would get your answer. Okay. I mean, you guys have used calculators before, so I'm sure you know how to do this stuff. But TI calculators, I found, because I used to use a TI 82 for my math courses, and it's very different from this one, right? So it's good for you to get used to the specific type of calculator that you're allowed to use, because for whatever reason, you're only allowed to use this calculator. You can't use the calculator on your iPhone, for example. So it's worth it to get used to how it works. So in this example, we're being asked to find the difference between 15,789 and 9,332. And once again, you're going to clear your calculator. So make sure that there's no previous work that's still in its memory for some reason. Okay. And then you want to enter the largest number first, because remember, it makes a difference. You want to enter 15,789 and then subtract that from 9,332. Press enter, and you have your answer. Same thing, you're doing a product. You want to start by clearing the calculator, enter the relevant number. In this case, we're asked to find the product of 309 and 68, right? And so like I was telling you guys earlier, when you see that word product, don't get nervous, because we already know that just means 309 times 68, okay? So you enter 309. The operation here is multiplication. So 309 times 68, press enter, and you've got your answer, okay? And I would suggest, if these terms like product, quotient, if they confuse you, it would be easy to write down the term and then write down the relevant operation and then memorize that, so that when you see it in a word problem, you automatically, it becomes part of your vocabulary, and you automatically know what they're asking you to do, right? Because in this case, if they're asking you find the product of 309 and 68, you don't want to subtract, right? And you certainly don't want to add, and you don't want to divide, because all those would give you the wrong answer, right? So pay attention to the terms that we've discussed today, so that you know what the question is asking you to do, and you can always find the right answer. Okay, here we're being asked to divide 12,456 by 12. And again, start by clearing your screen, and then enter the numbers followed by the relevant operation. In this case, it's division. Enter the divisor, which is 12. Okay, press enter, and you get your answer. Once you get the calculator, there are practice tests on page 570 to 575. And you can make it a little fun activity and just practice how to use the calculator. Or you can think about it as a fun activity if you wish. All right, so on to word problems. So when you're working with word problems, it's important to keep a process in your mind so that you don't lose track of what it is that you're being asked to do. So you want to read carefully the problem and understand what the question is asking you, and then only select information that you need to answer the question, because sometimes they'll give you extra information that you actually don't really need, right? So don't get tricked, okay? Don't get distracted. Read the question carefully and determine what information from the question do you actually need to answer the question. And we'll see some examples of what that means in a little bit. And then once you found your answer, you can check to make sense. So for earlier in our example, where we wanted to give the cashier $205 for an item that cost $67, right? When the cashier gives us our change, we'll know it's the right change because we'll add that change to the value of the item, and that should equal the original amount that we had in our pocket before we gave it to the cashier, right? So that's what they're just telling you here, is that once you find your answer, always check it to make sure that it makes sense, right? Because in that particular scenario, if you add, let's say the cashier gave you back $50 and you add 50 to 67, you know that that doesn't equal 205. So you know that the cashier shortchanged you, and you can say, hey, you owe me a little extra. This is not the right amount, right? So to pass the mathematical reasoning test, you need to be able to solve word problems. And these questions they're a lot easier to manage if you use a 5-step word solving process. Okay, and there are a lot of opportunities to practice that in the book. So the first step is that you want to ask yourself, what is the question asking me to find, right? So read the problem carefully and state the question in your own words. And that's a great way to, because I guess get past the nerves is like, okay, you've read the question. How would you explain that question to your sister or a friend? Like rephrase the question in your own words. And then you slowly start to, I guess, pull down that barrier of understanding, because now you have, once you're able to rephrase something, it means that you have some sort of understanding of it, right? So do your best to rephrase the question in your own words. And then the second step you need to ask is, what information from the problem do I need, right? And like I said earlier, sometimes word problems will give you extra unnecessary information that you don't need. And if you're paying attention to information that you don't need, it can lead you to the wrong answer. So the second step is for you to ask yourself, what information from the problem do I actually need to answer this question, right? And then the next question is, what operation do I need to perform? Is it addition? Is it subtraction? Is it multiplication, or is it division? And, as I stated earlier, a lot of times with word problems, they're not going to tell you directly add 5 plus 5 plus 5. What they'll say is, what is the sum? Or they're not going to tell you divide 50 by, or divide 5 divide 50 by 5, they're going to ask you what is the quotient of 50 and 5, right? And then you would know that that means that you need to divide 50 by 5. So step 3 is you need to determine what operation is the word problem asking you to perform. And then choose from any one of the 4 operations that we've discussed earlier based on your understanding of the question, okay? Then the 4th step is what is your solution? So carry out the operations with the numbers that you choose, because again, remember, there'll be extra numbers in that word problem that you don't need, right? So focus on the numbers that you need and then carry out your operations and then ask yourself, finally, does your answer make sense? And you can always check your answer using the methods that I described earlier, okay? Like either subtracting from the original or multiplying an answer that you find with a number that's in the problem to get an original number. There are always ways that you can check your answer. And, you know, if it might help you to try to rephrase questions in terms of stuff that you do every day, right? So if you see a question that says, Sally has 50 spoons, she went to the market and she saw 300 spoons, but she has guests coming over, she has 52 guests coming over. How many spoons does Sally need, right? It doesn't matter how many spoons are in the market. We know that she has 52 guests over. She already has 50 spoons. So she really just needs 2 extra spoons, right? So you would add 50 to 2 and ignore the number 300 because it's not going to factor into your final answer. Okay. So this is a little helpful kind of way to order the operations that you need to use, right? So if the question is asking you to combine amounts of different sizes, you know that you need to add, right? If the question is asking you to find the difference between amounts, you know that you need to subtract. If you need to combine the same amount multiple times, multiplication. And if you need to separate one amount into equal sized groups, you know that you need to divide, okay? So yeah, as I mentioned earlier, a lot of mathematical reasoning tests will, excuse me, include information that you don't need to answer the specific question. So be mindful of that and pay attention to that, especially with multiple choice questions, right? Because they will include information that you don't need and then have an answer that matches that information you don't need in your multiple choice, right? So I would advise you not to look at the answers, okay? Don't, if you can, try not to look at the multiple choice options. Try to find the answer on your own first and pay attention to information that you don't need. And then you can compare, because sometimes if you look at the answer first, it might deceive you in terms of what kind of operation you need to do and what kind of information you need to include, because you're like, oh, I saw 50 as an answer choice, and I see 5 times 10 is one of the required, is the information that's being given, so 50 must be the right answer. But then maybe 5 times 10, but you need to subtract 15 so that you can get to the actual right answer, right? I don't know, I'm just throwing stuff out there, but the point is make sure that don't let yourself be deceived by the answer choices, because sometimes the wrong answer choice is included based on using wrong information, right? So don't look at the answer choices first if you can. Try to figure out the answer on your own, and then try to match or see if the answer that you got matches any one of the choices, okay? So in this example, to cover a sofa, they're telling us that Sophie needs 12 yards of fabric that costs $14 per yard. And they want you to find how many yards, Sophia, not Sophie, sorry. They want you to find how many yards Sophia needs for 3 sofas. So what do you guys think we need to do here? So I can tell you right away that they're
It looks like you have to multiply the 12 yards by the $14.
okay. So they've already factored in the fact that most people will be distracted by the number 14, right? Because all you have to do is change this. So let's think about the steps, right? The first thing was to put the question in your own words, right? So change this from Sophia and just pretend that the question says, Jaleesa needs 12 yards of fabric that costs $14, okay? $14 per yard. How many yards?
Oh yeah, I see my mistake. I
Okay.
misread. It's 12 times 3.
Yeah. Okay. And sometimes it will help you. Like here it's saying yards, right? Okay, let me not go that route because I think that might actually make it more complicated. So
No, yeah, it's fine. I
okay,
literally just did what it said. They had extra information.
yeah.
My brain didn't process fast enough.
Yeah, and guess what? They have the answer 12 times 14 is 163, but that's the wrong answer. She really needs 12 times 3, which is 36. Okay. So again, pay attention. It will help sometimes, put the names of put your name, put the names of people that you know, make it personal. Like, okay, they're saying, I'm trying to buy fabric for my sofa, right? And they're not asking me about how much I need, they're asking me how much fabric I need for the sofa, okay? And sometimes if you personalize it, it can make it a lot easier for you to think because, okay, what would you do in a normal situation if you're going to, like, for example, Walmart, or I don't know, where they sell fabric to find fabric for your sofa, right? So sometimes personalizing the question can make it easier for you to answer it. So yeah, like we talked about already, the correct answer is 36 yards of fabric, and the question asked you to find the total number of yards of fabric that Sophia needs for 3 sofas. And note that the cost of a yard of fabric is not needed to answer the question because it's not asking you how much. If it was asking you how much, then 3 yards wouldn't matter because you would multiply, what was the number? 12 by 14 and you would get 168, right? Because if it was asking you how much it would cost for Sophia to buy 3 yards, right? Then you would multiply 12 by 14, but it's asking you how many yards Sophia needs. So you would multiply 12 by 3. Okay. And since you were asked to find the amount of fabric for 3 sofas, you should multiply 12 yards per sofa by 3 sofas, which is 36 yards. So here are the 2 common errors that you want to avoid. if you had mistakenly divided, you would have gotten the incorrect answer of 4 yards instead of 4 yards of fabric for 3 yards, right? So again, you want to make sure that you understand what the question is asking you. How many yards does she need? You don't want to divide here, right? What you want to do is multiply, because if you have 3 sofas and each one needs 12 yards, the first sofa will need 12, the second sofa will need 12, and the third sofa will need 12. So 12 3 times, or 12 times 3 is 36, not 12 divided by 3, because you would get 4 yards, and that would not be enough for 3 sofas. So you can actually talk yourself through these problems as well. Like, okay, let's say I have 3 sofas. Will 4 yards be enough to cover 3 sofas? No, right? So you know from that maybe dividing is the wrong operation here, because 4 yards would not be enough. Okay. And then the second common mistake is if you had used 14, like we talked about earlier, and you multiplied that by 12, you would be tempted to put the wrong answer. And as you can see, they put both wrong answers there, right? They put 4 and they put 168. And so that's why I was telling you, talk yourself through it first, and then try to get your own answer, okay? And then compare what you get so that you're not distracted by the wrong answers, okay? And there are, again, lots of practice tests starting on page 578 to 580. And the good thing about these practice tests is that, you know, don't be afraid to do them and get them wrong. Like Jaleesa, that was a great attempt, because now you know what you did wrong, right? And so when you see similar questions, now you know how to answer them, right? So sometimes, I shouldn't say sometimes, I think with math, getting stuff right, getting stuff right is great, right? If you get it right the first time, fantastic. But if you get it wrong, don't feel bad, don't feel disappointed, because it's a learning opportunity. You can pay attention, you actually learn more from stuff that you do wrong, right? Because then you can figure out, okay, oh, this is what I was supposed to do. Like you said earlier, Lisa, I know exactly what I did wrong. Now you know, right? And I feel like now you actually have a deeper understanding than if you had gotten it right the first time, because if they had changed a wording slightly, maybe you would have gotten it wrong on the second attempt. But now that you actually have an understanding of what happened, if they change the wording, you've learned from your mistake, and you know, you're not going to trick me this time, because I know it's not about the price, you know, it's about the number of yards, right? So don't be afraid to get stuff wrong. When you get stuff wrong, actually like celebrate a little bit, because it gives you it gives you an opportunity to learn what you did wrong, okay? And that's actually, I think, how you master a subject. When you get it wrong, you can look at what you did wrong, and you form a deeper understanding of what you're doing, okay? So we have a few slides left. Are you guys okay?
Nope, I'm good.
Okay.
It's okay.
All right. So the word problems that we just covered, they're only one sort of operation, or only required one operation to solve, right? So there are some word problems that require several steps, right? And so these are called multi-step problems. And when you're working on multi-step problems, there are 2 important ideas that you want to keep in mind, right? The first one is, again, what is the question asking me to find? Okay. And the second idea is, did I actually answer the question, right? So if we want to quickly go back to the issue with Sophia and her couch, if you had answered that she needed 4 yards, you could check yourself by asking, okay, in real life, or if these were my 3 couches that I needed to cover, would 4 yards be enough? You know, and the answer is no. And if the answer is no, you know that you didn't answer the question. And you can revisit the question and try to rephrase it in a way that helps you understand how to answer. Okay. So in this example, to win a prize, Sarah's daughter has to sell 75 boxes of cookies, excuse me, in 3 days. If she sold 16 boxes on day 1 and 34 boxes on day 2, how many boxes would she need to sell on day 3 to win the prize? So ignore the answers, okay? Let's try to figure this out. Okay, so the first thing we want to ask ourselves is, what is the question asking me to find? So the question is asking us to find how many boxes Sarah's daughter needs to sell on the 3rd day to make her goal of 75 boxes, right? So if it helps you, you can rename Sarah, maybe add your own daughter's name if you have one, or maybe put your own name, okay? And that actually then makes it easier. Okay, if my boss tells me I need to sell 75 boxes and I sold 16 on the first day and 34 on the second day, how many boxes do I have left to reach that 75 mark, right? And so we know the total number of boxes that she needs to sell is 75. We know that she's already sold 16 on the first day. We also know that she's sold 34 on the second day. So what do you think what operation do you think is needed to do the next step?
Find the totals sold on day 1 and day 2.
Yeah, exactly. And then once you've done that, 16 plus 34 is 50. What do you think we need to do next?
Find how many boxes she has left to sell.
Exactly. So you would subtract 75 because that's the goal from 50, the ones she's already sold,
Mhm.
and we'd get 25, right?
Right.
So yeah, that's the solution here. 75 boxes minus 50
This is-
equals 25. And we know that that's the answer, right? And so the next step is then to ask yourself, well, does my answer make sense? Did I answer the question? And by taking this additional step, you ensure that you answered correctly how many boxes need to be sold on day 3, right? So the sample multi-step problem involved only 2 operations, adding and then subtracting, adding the 2 numbers that she sold on the first and second day, and then subtracting that total from the goal, which was 75 boxes, right?
Okay.
On the actual test, you may need to do 3 or more operations to answer a question. So really read and think carefully about each question. And again, always try to personalize it. Maybe think of the question in terms of money, uh, money that you have to spend on a bill, money you have in your bank account, money you have to share among your friends, you know, a goal that your boss has asked you to meet, whatever it is that you feel can help you make the question a little bit more accessible and fit the activities that you already do. Because you guys, you know how to do this stuff, okay?
Yeah.
It's just a matter of understanding it in terms of everyday activities that you, or activities that are already a natural part of your life, okay? So as you think about the example, I guess note that the most common mistake that people make with multi-steps problem is that they stop short of answering the question, right? Notice that choice 3, they actually gave you 50. And if you had looked at 50 and you had added 16, what was it? What was the other number?
34.
Yeah, thank you. If you had added 16 and 34, you would have thought, oh, the answer is 50. And that's a partial answer. It's not this, it's a partial solution because yes, 16 and 34 is indeed 50, but it's not the complete solution to the problem, right? Because you still need to subtract 50 from 75. So don't let yourself get distracted. Always prompt yourself by asking, okay, so have I fully answered the question? Is there anything else that I need to do that will help you avoid mistakes or traps that the problem may contain, okay? So again, practice makes perfect. Don't be afraid to get stuff wrong. Don't be afraid of the practice problems. They're out there. See them as your friends. See them, they're there to help you. And the more that you do them, the more comfortable you get with the style of questions, the more confident you get about answering the questions. Even when you get them wrong, you can learn from your mistakes. And then also you want to get comfortable with the vocabulary because they're not always going to add you to, excuse me, they're not always going to ask you to add. They might phrase it in a way that contains keywords that lets you know, okay, I should add here, right? But it's not going to specifically say add this number, right? Like that example we just saw, it didn't tell you to add 16 to 34, but you know automatically that you needed to add, right? Based on the way the question was phrased. So do work on the practice problems as much as you can. And if you have any questions at all, again, don't hesitate to contact me, okay? So we're almost there. This is actually the last lesson in this chapter, and it's on distance and cost. Okay, and this portion of the lesson is on notation, right? And the goal is to understand that there are different ways to indicate multiplication. So n times r is the most obvious, but when n is written next to r, nothing in between, you know immediately that that means multiplication. This notation is very common when you're dealing with functions, and we'll get to that like later on in the semester. But when you see n written outside of parentheses and r inside the parentheses, you know that they're telling you that n is a function of r, excuse me, r is a function of n, and that you need to multiply n by r, okay? And this is popular or common when you're doing the dot product. Actually, the dot is a lot higher, but this essentially also indicates multiplication, right? So these are different, I guess, methods of conveying that the function or the operational, the operation that's needed is multiplication. So these, I guess, are two ways to indicate division. Either C with the division sign followed by n tells you C divided by n, or you can write C with the divisor line and underneath also indicating that division is the operation here. And then you can rewrite a formula to solve for its variables. So in this particular formula, we have three variables. We have C, we have N, and we have R. If you were asked to find R, for example, what you would do is you would divide both sides by n, right? And on this side, since we have n here, n would cancel n, the n in the dividend would cancel n in the divisor, okay? And so you can think of them as equal parts, and you would be left with r. And then your final operation would be c divided by n over r equals r, right? Or if you were asked to find n, you would divide both sides by r. So r would cancel each other out on the right side, and you would end up with c divided by r equals n, right? So do you understand what's happening here? If we can put it in different words, whatever you're asked to find is what you need to define, divide both sides of the operation by. So if you're asked to find r, just divide both sides by r, okay? If you're asked to find n, divide both sides by n, and whatever side you see a particular variable repeated. So if you see n repeated on the right-hand side, you know that n cancels n, and you would have c divided by n over r. And if you see r repeated on the right-hand side, you know that r cancels r, okay? And then you would have c divided by r equals n. Okay, does that make sense?
Yeah.
And you can apply that concept to absolutely any grouping of variables, and you'll see how it makes sense in the next couple of examples. But again, the same concept is being repeated here. If you're being asked to find t, you divide both sides by t. T would cancel t on the right-hand side, and you would have d over r equals t, okay? And if you're asked to find r would cancel r on both sides, on the right-hand side, and you would have d over t equals r. I know it's a little bit, I wish I could write it out. I think it would be a lot easier. But let's look at some examples and it might make more sense, okay? So on the math reasoning test, you'll see questions that will ask you to, that will require you rather to apply formulas. And when a relationship is constant, you use a formula to set up the information about how the different parts relate to each other, right? So one of the most commonly tested formulas has to do with distance, rate, and time. And distance is the product of the rate at which something travels and the amount of travel time. So here again, we see that word product. We immediately know that that means distance equals rate times time, because it's telling you that distance is. So when you see that is, consider it your equal sign, right? Distance is the product of rate and time, okay? Or D equals RT, okay? So that's why I was trying to tell you earlier that word problems aren't necessarily, they're not going to specifically tell you, hey, you need to multiply rate by time to get distance. But when you get used to the vocabulary, you know that reading the sentence, you can deduce that distance equals, is, if you're saying this is my book, right? That means when you point to a book, that's equal to something that belongs to you, right? This is my book, right? So consider, I don't know if that was a good example or not. If it wasn't, I'm very sorry. I'm trying to make it as accessible as possible. But when you see is, consider it an equal sign, okay? So distance is a product. We know that multiplication is involved here of, okay? Of is telling you what are the variables involved, right? Rate and time, okay? Note that the letters of the variables can be used to represent the different parts of a formula. So a formula really just allows you to substitute known values for certain variables and solve for the unknown variable. So instead of writing out this entire sentence, you can just with shorthand write the formula D equals RT, and it means exactly the same as this entire sentence, right? But mathematicians, they like symbols, right? So the good thing about getting used to the vocabulary that's used is that when you read a sentence like this, you know exactly what functional operation is being used because you recognize the keywords that are being used here. Okay, you have is, which is your equal sign, a product, right, which is your operation, of, which follows, which usually precedes, not follows, sorry, which precedes whatever variables that you need to include in your formula, okay? And I think that with the examples that follow, it should be a little bit clearer. So in this example, we're being asked to determine how many miles you can travel if you drive at an average speed of 55 miles per hour for 3 hours, right? And again, this is another activity that you guys do all the time, right? And this is probably something that you figure out without knowing that you're calculating distance equals rate times time, right? Or so, you know that the rate is 55 miles per hour and that the time is 3 hours, right? And so you want to substitute the information that you have into your fancy formula that we saw earlier, D equals R times T. So we're trying to figure out the distance. We know the rate, we know R, and we know T. So that's pretty easy, right, guys? Because we can figure out the distance. Okay, so all we need to do is multiply 55 by 3, and you would get 165 miles. So revisiting the question, how many miles can you travel if you drive at an average speed of 55 miles per hour for 3 hours? Well, all you got to do is multiply 55 by 3, right? Because that's your speed that you're going, miles per hour. And that's the length of time that you're doing that, 3 hours, okay? And in 3 hours, if you're driving 55 miles per hour, how much distance can you cover? Well, the answer is 165 miles. And how did we get that? We just multiplied 5 by 3, okay?
Okay.
So yeah, this is another really good test tip. You want to substitute the values for variables back into your formula to check your answer. So don't be intimidated when you see formulas like this, okay? Just know that you can easily, all it's telling you is that D represents something, okay? Just in this case, it's distance. And that distance is equal to how fast you travel, or the rate of your speed, and how long you're traveling at that rate, okay? So this is, it's easy, right, guys? Don't get intimidated by the formula. Just know that it's you know, it's the mathematician's way of communicating to you. They don't like to use words, right? They like to use symbols, right?
Okay.
An English teacher would tell you straight up, right? They would read the center. So think of it that way. And then don't be intimidated. Just know that you can substitute the values into the variables represented by whatever symbol that they choose to use, and go from there, okay? So another helpful formula is one that involves cost, right? It's the cost formula. So it expresses the relationship between cost and the rate per unit. So note that the wording per means for every 1 unit, right? And that's, we can put it in simple terms. If you want to buy some cookies and you see 5, you ask the person selling, hey, how much are your cookies? And they'll tell you, oh, it's $5 per cookie. And that just means that each cookie costs $5, right? So don't get hung up on the terminology. Just know that mathematicians like to use their own language, but you can easily translate it into something that makes sense to you, okay? So the formula for total cost is the number of units multiplied by the price of units, right? Or C equals NR. And like, again, this, don't be intimidated by this. It's just telling you that the cost of your cookies is equal to the number of cookies that you have multiplied by the price per unit, right? So in this case, if each cookie is $5 and you want 10, 5 times 10 is 50, right? And that's going to be your C here. That's all, guys. Okay, it's not, don't get hung up on the symbols here. Okay, so in this example, you're at a bakery and a package of frosted cookies is priced at $3 per package, right? And if a teacher treats her class by buying 4 packages, how much would the cookies cost before tax? Very simple, right? We go back to our formula. C is the cost. How much will it cost her? Equals N, the number of cookies that she needs, multiplied by R, the price, right? And so you know that the number of units for packages and the price per unit is $3 per package. So you simply substitute that information into your formula. 4 times 3 is 12. And so you know that it's going to cost her $12, right? So for any formula, once you know 2 variables, you can always find the third. And a variable just simply means a value that can change, right? So they're telling you N can be any number. It's a variable, it varies. It can be 4, it can be 10, tomorrow it could be 12, right? So right now we don't know what the value is, so we're just going to put N, right? But just know that that N is related to the number of units, right? That can change tomorrow, right?
Yeah.
And then R, again, same thing. It's a variable, meaning that today it could be $10, but tomorrow, if I feel like it, I could price this at $15, okay? That's my prerogative. It's what I want to do, okay? So again, don't be intimidated by the word variable. It just simply means a value that changes. And right now we haven't determined what that value is. So we're just going to put a placeholder. Okay. Okay. And then this next example, Max has bought a set of 4 flower, 4 flower mats for $44. How much was the price per flower? Why did I say flower? I think I'm tired. How much was the how much was the price per floor mat, okay? And again, you could replace the name Matt if it helps you with your own, okay? You just bought 4 floor mats for 44 bucks, and you get home and your mom or your spouse asks you, so how much was each one, right? Um, so this is, we go back to our cost formula. We know that cost equals a number of units multiplied by the price per unit. But in this case, we're trying to find
The
R,
price per unit.
right? We're trying to find how much each individual format cost, right? So what we're going to do is divide both sides by R. And R would cancel out R on this side, okay? And so, excuse me, we're dividing both sides by N, I'm really sorry. So N would cancel out N on this side, and you would end up with R equals C over N, okay? So again, we're canceling, we're dividing both sides by N. N would cancel out N on the right-hand side. And
The price per unit.
the price per unit would now be your dependent variable.
The
So
cost on the number of units.
thank you. So on the left-hand side will always be what you're looking for, okay?
Yeah.
Whenever you do your operational changes to change the variable in question that you're looking for, you'll always have what it is that you're looking for on the left side. In this case, we're looking for the price per unit, R, right? And so that's going to be on the left-hand side. If we were looking for cost, it would be, so cost meaning the total price, which was 44 bucks,
Yeah.
C would be on the left-hand side. But here where you looking at the price per unit, right? Not the total cost, but the price per unit. And that's symbolized by R, which is, again, ends up on the right-hand side after we've done the necessary operations to cancel out N, right? So we then substitute the known values in the into the cost formula. So we know that the total price was 44, which is C here. And we know that the number of mats that we bought was 4, which is N here. So 44 divided by 4 gives you 11. Okay.
Yeah.
Do you guys have any questions?
Yeah.
Okay. Yeah, practice tests on distance and cost start on page 588 to 591. So work on those. And that essentially brings us to the end of tonight's lecture.
Okay.
I don't know, how are you guys feeling? Is there a portion that you want me to maybe revisit? Is there anything that came to your mind that you were thinking that maybe I should have slowed down a little bit or could explain a little bit more?
For me, it's okay, but about the practice, I don't have the book yet.
Oh, okay. When do you think you'll get the book?
I received a message from Leonard saying that she's gonna send it to me.
Okay,
I give her the address, so I'm waiting.
okay. So that probably means you won't have it by the next class. I'm not sure.
I'm not sure.
But what I could do is I can put the practice tests on a slide
Okay.
and upload them to Google Classroom. Were you able to view the slides for this lecture?
I tried to find it, but I don't see it.
No? Okay. All right. So I'll try again to upload the slides. I'm not sure what's going on there because but I'll try again and you guys can let me know. I'll add the practice problems.
Okay.
And then just let me know, or actually, let's do it this way because I'm thinking about the book, the practice problems, they're quite a lot. So
Okay.
what I'll do is I'll give you guys time until you get the book
Mhm.
to
I have the Kaplan GED prep book. It's just the pages are different. I'm still following along, but
oh, okay.
my
Okay.
pages in my book is in the 200s, not 5.
Oh, really?
Yeah, but it's the same stuff.
Okay. Okay. So I'll just give you guys no, because I think that will put you behind. Okay, I'll try to upload the excuse me, the practice problems for those who don't have the book. I'll try to do that by tomorrow.
Okay.
That way you can start working on the questions. Yeah.
And about Thursday,